Hello everyone. So today in this lecture we are going to learn about the classification of organic compound, which is from 11th standard chapter Basic Principles of Organic Chemistry. So organic compound can be classified mainly on the basis of their structure and on the basis of the functional group. In this particular lecture, we are going to learn the classification on the basis of structure. Then in the next lecture, we will learn classification on the basis of functional group. Since it is very important to memorize some of the functional group before learning them in detail. Okay. So here, whenever you come across the term organic compound, just remember that the carbon will be there. Okay. Just understand that carbon will be there. Now, as you all can see this chart of classification, okay, so now let's learn them in detail. So here, on the basis of its structure, organic compound can be acyclic, open chain or aliphatic. Another one is cyclic or closed chain. Okay. Here let's consider one example of a chain. Suppose this is a chain, okay, and these two are the ends of chain. If I join these two ends of a chain, okay, then it form a ring, okay, it form a ring like structure, or you can say it will be closed. So this kind of structure is known as cyclic or closed chain structure. Similarly, when organic compound form, organic compound mainly the carbon atom, okay, when carbon atoms are joined together and form a closed structure, ring like structure, okay, it is like a ring, it is a closed structure, then that type of structure is known as cyclic or closed chain structure. Okay, all these are carbon atom which are connected through these bonds, okay, and all the ends are joined together, okay, and it form a closed chain structure. So that type of structure is called as closed chain or cyclic structure. Similarly, if I do not join both the ends of a carbon atom, okay, if I do not join these two ends of a carbon atom, then here also there are 4 carbon atom, okay, and here also there are 4 carbon atom, but in this case I have joined two ends of a carbon to form a ring, but here I do not join the two ends of a carbon, right, I do not join the two ends of a carbon, so it will be like a open chain. So this type of chain is known as open chain or acyclic. Acyclic because it does not form any kind of a cycle. It may be a straight chain or it can be a branch chain. So the molecule which are formed when atoms are joined together to form a straight chain or branch chain structure, that type of structure is known as acyclic open chain. It is also called as aliphatic. This name you have to remember. Okay. Now, aliphatic or open chain compound will not be further subdivided, but cyclic or closed chain compound can be homocyclic or carbocyclic and heterocyclic. From the name itself, it is clear that what is clear that homo means same, okay, homo means same, and cyclic means cycle. That means here also there will be a cycle because it is a type of cyclic compound, so there will be a cycle, but this cycle form with the same number of atom, form from the same number of atom, and that atom will be carbon atom, and that atom will be carbon atom, because we are learning about the organic compound. So the compound in which the ring is made up of only carbon atom, that compound is known as homocyclic compound. Okay, as you can see here in the example that this compound is made up of only and only carbon atom, that is same atom. Okay, this compound is also formed with a same number of atom, same atom, that is carbon atom. Okay, and it is also known as carbocyclic. This carbo word comes from carbon. This carbo words comes from carbon. So it is also known as carbocyclic because it is made up of only and only carbon. Next, heterocyclic. Here also name itself clear that hetero means different. Hetero means different, cyclic means cycle. That means whatever the cycle is forming here, that cycle will be formed from different atom. Okay, carbon is there, but along with carbon, other atom will also be there. Like for example, see in this example, all four atoms are carbon, but oxygen atom is also there. Okay, O represents oxygen atom. So because of this oxygen atom, this compound will become a heterocyclic, different atom. Here also carbon atom is there, but along with carbon atom there will be a nitrogen atom. Because of this nitrogen atom, this compound will be heterocyclic compound. Okay, so same definition here also, but the difference is along with carbon atom, other atom will also be there, like nitrogen, sulfur and oxygen. I hope I have made this concept very clear to all. Now let's move on to the next part. See here, both homocyclic and heterocyclic will further subdivided into other parts. Okay, so let's see. First we will learn about homocyclic, then we will move on to the heterocyclic. So homocyclic compound can be alicyclic and aromatic. First we will learn aromatic compounds. What are aromatic compound? Then we will move on to the alicyclic compound. So the compound which are aromatic, they have special stability. They have unusual stability. Okay, remember this. The compound which shows aromatic character always have special stability. Okay, for a compound to be aromatic, there are some conditions. The very first condition is the compound should be cyclic. Okay, the aromatic compound should be cyclic. Second condition is it should have conjugation, be conjugated. That means it should have conjugation. What is the conjugation meaning? So see here, suppose if I draw this ring, okay, this ring, and if I draw double bonds at the alternate position, this is a single bond. Okay, then if I draw one more bond, then it will become a double bond. So if I draw double bond at the alternate position, that means double bond, then single, double, single, double, single, alternate position पे single double bond, then that type of compound will show conjugation. Okay, this is a conjugated compound or conjugated structure. Okay, now third condition is it should follow 4n plus 2 pi rule, where n is equals to 0, 1, 2. For now you just remember this part, that is 4n plus 2. It should follow this kind of rule. Okay, in the another lecture we will learn it in detail. Next, the fourth condition is delocalization of electron. Okay, now see here, this bond contains 2 electrons. Each double bond contains 2 electrons. Okay, if these electrons moves inside a ring, okay, if these electrons move inside a ring, then that movement of electron inside a ring is called as delocalization. So it is a movement of electron. It is a movement of electrons inside a ring. Movement of electron inside a ring is called as delocalization of electron. So it can also be shows like this. Okay, this double bond also shows like this. And this type of structure, if any structure contains 6 carbon atom and alternate single double bond, then that kind of structure is known as benzene. You have to remember this structure with a name. Okay, this type of structure is known as benzene, 6-membered ring. Okay, it is a 6-membered ring with alternate single and double bond. Now aromatic compound further divided into benzoid and non-benzoid. So benzoid word, this benz word comes from benzene only. Okay, this benz word comes from benzene. So if any compound contain a benzene ring, then that type of compound is known as benzoid. That type of structure is known as benzoid structure. So you can see here in this example, this structure contains a benzene ring, so it is a benzoid. But in the case of non-benzoid, it do not contain a benzene ring. Here you can see it is not a benzene ring. Okay, if I draw here this ring, then it will become a benzoid, but here this ring is not present. Okay, is not there, so it is a non-benzoid structure. I hope this much is clear to you all. Now let's move on to the alicyclic. Alicyclic, see here, cyclic word comes, that means it is a cyclic structure. Okay, the structure will be closed. Whatever the structure is, that structure will be in the form of closed chain. Okay, now Ali, this Ali word comes from aliphatic. Aliphatic. So it is a cyclic structure, but it exhibits a property which is similar to aliphatic compound. Aliphatic compound. Okay, in the earlier part we have already studied what is aliphatic compound. Okay, so it is a cyclic structure, but it exhibits a property which is similar to aliphatic compound. So see here, organic compound containing cyclic structure. Okay, cyclic structure, but does not shows aromatic character. Obviously it does not show a aromatic character because it is a aliphatic. Aliphatic is what? Acyclic or open chain compound. Okay, it is a cyclic, but it exhibits some property which is similar to aliphatic compound. Okay, so obviously it is not aromatic, because for aromatic the compound should contain a double bond. Okay, now second definition you can write is it exhibit a property similar to that of aliphatic compound. Okay, now see here this example, it is a cyclic compound, but it does not contain any alternate position single double bond. It does not have any type of conjugation. That means it exhibit a property which is similar to aliphatic compound. Okay, I hope this much is clear. Okay, now let's move on to the heterocyclic compound. We have reached at the end of the topic. Okay, so here heterocyclic compound can be classified as heterocyclic aromatic and heterocyclic non-aromatic. So heterocyclic, that means cycle is formed with a different atom, carbon atom along with other atom, as we have already studied. Okay, now aromatic also we have studied. Okay, in the previous part. So heterocyclic or aromatic, two terms are coming here. Okay, so it is a aromatic ring. Obviously it is a aromatic ring where one or more ring atom are not carbon. That means one or more than one ring atom are not carbon. It should be a different than carbon atom. So here, see here in this example, it is a cyclic ring. Yes, then hetero means one or more ring atom. Here one atom is different, that is one atom is oxygen atom, others are carbon. Different atoms, carbon and oxygen, two different atoms are there. That means it is a heterocyclic ring. Now it should be aromatic, na, right? It is a type of heterocyclic aromatic compound, so it should be aromatic. So let's check here. So here it is a cyclic. The first condition for aromaticity, that it should be a cyclic. So this is a cyclic compound, so first condition is followed. Second is conjugation. Yes, obviously here conjugation is there. Double bond single bond, double bond single bond, alternate position पे double single bond है, that means conjugation is also there. Now third condition, 4n plus 2 rule. Okay, 4n plus 2 pi rule. These two double bonds each contain 2 electron. One double bond contain 2 electron, another double bond contain 2 electron. Here oxygen also carries 2 electron. That means total number of electron is 6. If I keep n is equals to 1, then 4 into 1 plus 2 will be equals to 6. Okay, that means this rule is also followed. Now last condition is it shows delocalization, that means movement of electron. Okay, so here these electrons move inside the ring. That means fourth condition is also followed, delocalization of electron. So this is a type of heterocyclic aromatic ring. Here also same condition will be followed. So it is also an example of heterocyclic aromatic ring. Now similarly, see here, in the case of heterocyclic non-aromatic, the compound is heterocyclic but non-aromatic, that is the compound should not show aromatic character. So it same definition will be there also, but in case of aromatic ring, here non-aromatic will come. So it is a non-aromatic ring where one or more ring atom are not carbon. See here, it is a cyclic, contain one different atom, that means heterocyclic compound, but it is not aromatic. Why? First condition is followed, but what about second condition? This compound does not contain any double bond. Okay, all are single bonds, that means conjugation is not there. That's why this is non-aromatic, not a aromatic compound. I hope all this classification part clear to you all. Now see here, these are some exercise question which you all will try. I will explain you one, then rest you will try. Okay, so see here, the first example is of glucose. You have to mark the carbon atom. Okay, so in this case, first this is a carbon atom. Okay, this point will also show a carbon atom, second carbon atom. This is third carbon atom. This joining point, okay, this joining point through these two bonds shows or represent a carbon atom. This will also represent a carbon atom. This is also represent a carbon atom. Okay, so 1 2 3 4 5 6. So there are total 6 carbon atoms. Similarly, for rest of the compound you have to mark the number of carbon atom. So that's all for today's lecture. Next we will learn in the next lecture. Next topics like classification of functional group we will learn in the next lecture.